right, so today we're going to talk about the different types of reactions, and we have 5 that we're going to talk about. You're going to fill out a foldable if you so desire, depending on if you're a pre-AP or not. Regular chemistry, we're going to encourage you to fill out a foldable, and we're going to be on the inside of our foldable, and what we're going to be doing is we're going to be working our way to the inside and then out, or inside and out, depending on which way that we're going. So the first reaction that we're going to talk about is synthesis. Okay?
Synthesis.
So our first general thing, just a general word equation, is that it is an element plus an element makes a compound or yields a compound. And we want to write a general equation for this, meaning that we want to substitute letters instead of words.
Right. So we have element A, it's element B, make a compound A, B.
Okay. Looks pretty simple.
Because synthesis means
making something new, like photosynthesis.
we're putting them together, making something new. So we put 2 of them together and made something new. Okay.
So we have an example equation down at the bottom just to kind of make you, so that you can see what it looks like if it were to be an actual chemical reaction that you see. We have 2 elements, magnesium and nitrogen, react to produce, what do we call that again?
Magnesium nitride.
No prefixes because it's not covalent.
All right.
Okay. So now we're going to move to the left of your synthesis box because we're going to fill out the general
Cameras go backwards.
the general definition for synthesis. And your general definition is that we have 2 substances combined to make a single compound. Again, general means it's not going to happen every single time, but most of the time it will. And our helpful
Could
hint,
have 3.
Could have 3. Our helpful hint is that we are looking for one product.
Just 1.
Okay. So, next reaction we want to talk about is decomposition. Our general equation for decomposition is we have one compound breaks down into into 2 simpler substances.
Because if we're decomposing, we're breaking apart.
Exactly.
So we have compound AB breaking down to A plus B.
Alright, so it looks like in our example equation, we have sodium chloride, that's one substance, breaking down into 2 simpler substances, sodium and chlorine.
Ta-da!
Right, again, we're going to move to our left of your decomposition box to fill out this one. Our general definition for decomposition is that it's a compound breaks into a simpler substance. Similar to what you'd think of for what we just said for decomposition.
Pretty straightforward.
So, helpful hint. On synthesis, we had one product. For decomposition, we had one
reactant.
Reactant. Okay. Alright, so the next equation that we're going to talk about, or chemical reaction, is going to be single replacement. So now we're at the very top of your 3rd column on the foldable. Our word equation for this is we have typically an element plus a compound yields a new element and a new compound. So our general equation for this would be
A plus BC equals AC plus B.
Too cool. Alright, and if you're in pre-AP, you're going to have to be predicting products for this. Super fun. So let's look at the equation down below and look how they do, or kind of take a glance at how they do their switcheroo.
Mm-hmm.
So we start with zinc, and it reacts with
silver nitrate,
and then all of a sudden we produce zinc nitrate and then just silver all by itself. So we had a single element switch out and make a new single element.
So it's switching with this one.
So
because those are both metals.
Both metals. What do we? Metals are what charge?
Positive.
And we call those
cations. Because cations are positive.
So on this one, you can either have your cation switching places or your anion switching places, depending on what your single element is. This will be mostly for pre-AP to help you out with your predicting products, which Ms. Copeland will talk about in a later video. Okay, so now we're going to move to the right of the single replacement box. And our general definition for single replacement is that we have one element replaces another element in a compound. Our helpful hint to ID single replacement is generally it looks like an element plus a compound. And it's going to be on both sides of your arrow. It will look like an element plus a compound, and it gives you a new element plus a new compound.
Yep. When you go through them and you say single element, it's usually going to be a single replacement.
Okay. All right. Next one is a double replacement. So our word equation is we have two compounds yielding two new compounds. And our general equation for this is going to be
AB plus CD making AD plus CB.
Now, does it matter which letter goes first and which one goes second?
Does. Same thing as before with the predicting products. The positives have to stay in the front, the negatives have to stay in the back. Cations in front, anions in back.
Okay.
So the A and the C started out in the front, so the A and the C have to stay in the front.
All right, that makes sense.
So K and BA have to stay in the front, and so we're going to switch the polyatomics out to change who they're with. Okay? We can't switch the first and the last because then we'd just be writing the same thing but in a different order.
Okay.
So really we're just going to switch the last ones.
All right, so we're
Or the
just
first
making
ones.
a new plus minus pair if you break them up in their cations and anions, right?
Right.
Okay, not too hard. Okay, so now again we're going to move to the left to fill out our general, right, sorry. Okay.
We don't know what left from right.
So our general definition for double replacement is that we have two compounds react to make a new cation-anion pair, what we just talked about. So your helpful hint for this is going to look like double compounds. We've got a compound plus a compound, and it gives you a new compound plus a new compound.
Yep, two compounds.
Okay. So last but not least, we have combustion, my favorite. Okay. Yes. All right, so combustion reactions, if you look at the entire equation, it's only going to have C's, H's, and O's in it. And when you have the actual blank that is right here, that's meant to be blank because that's for your blank carbon compound, because the carbon compound that you have that's going to react can vary. And it's always going to react with oxygen, so you will always have O2 as a reactant, and it will always produce CO2 and H2O, carbon dioxide and water.
Every single time.
All right, so our general equation for this is that we're going to have some kind of carbon compound made up of C's and H's, maybe something else thrown in there, possibly,
any
oxygen.
Any numbers down there.
And it's going to react with O2 always, and it's always going to produce CO2 and H2O. Beautiful.
And so we can see, even on our example, again, we have a carbon-hydrogen compound, 4 and 8, but whatever, with our oxygen, making, again, CO2 and water.
Now, when I look at that, just the beginning from what we said, it looks like a single replacement reaction.
It kind of does, except that in a single replacement, the O would have switched with, like, the H or the C, and we would have ended up with a single element and a compound at the end. Instead, we ended up with two compounds. So, look for your products.
All right, so now what we're going to do is we're going to look at some example equations. One more. Carbon compound reacts with oxygen to form carbon dioxide and water. That's our general definition for combustion. It releases energy in the form of heat or a light.
Very commonly, you get an explosion.
Okay. Now, your helpful hint. This one's actually written on the screen for you since it's so long. It's going to be hard for us to write it out. What you want to do is, when you're looking at it, just like what we said, it looks like a single replacement reaction, but you have to be aware that oxygen is a reactant and CO2 and H2O are products. And that's the key thing. Okay. So now, you have a list of type of reactions. We'd like for you to take a minute, pause the video, and see if you can try to figure these out on your own, and then come back to us while we step you through how to figure it out if you're having trouble, or just check yourself.
Here on our first example, Na, which is an element,
Yeah.
single element, with a compound, breaking into a different single element and a different compound.
So an element plus a compound, you were saying single. That
Single.
kind of give it away. A single element with a compound, or single compound, so single replacement.
Single replacement.
Okay, next one.
We have just one compound breaking apart into two elements.
Breaking apart. It's like you're using all these key words on me. Like breaking down. So I'm going to say decomposition.
Decomp.
All right.
Yay!
So next one. Looks like I have
Got a long compound,
and then a single element.
a single element, and then two compounds.
Ooh, so it's not single replacement.
It's not, because we didn't have another single on our side.
So, it starts with a carbon compound, and oxygen is a product or a reactant, and CO2 and H2O are products. So I'm going to say combustion.
Yep. See a lot of C's and O's?
And H's.
Combustion. Yeah, but see, like,
Aha! I got
CO, yeah.
it. Okay.
Yeah.
Yeah. Whoa, this is a big one. Lots of big things. I have a compound, a compound, a compound, and a compound.
They look like that. It's probably a double replacement.
Double compounds on each side, double replacement.
Ta-da!
All right. Last but not least, we have two single elements and one product. It looks like we're putting two things together to make something new.
Yeah, they're coming together.
So making something new is synthesis.
Yay!
All right. Time to try it on your own. Till next time.